Hello everyone. In this session, we are going to see some of the basic definitions that are used in the subject electric circuit analysis or network analysis or network theory. Let us see what are the topics that we are going to see in this particular session. Network elements, network, circuit, open circuit, short circuit, branch, node, loop, and mesh. It is very essential to know these definitions before going to proceed with the other concepts of this subject. So let us proceed. Network elements. The individual elements such as a resistor, inductor, capacitor, diode, voltage source, current source, etc. will be called as network elements. Network. Network is nothing but interconnection of various elements. Those can be either active elements or passive elements, and the network may or may not have a closed path. For example, if you just represent a network by just a pure resistive elements which are fall into the category of passive elements, this kind of representation is also called as a network. If you observe this network doesn't have any closed loops. Okay, so then also we can call this as a network, and it may have one or two closed loops also. Then also we can call this a network. It means that your network may or may not have a closed path. Okay, there is no compulsory that the network must have a closed path. The example for the network can be like this. So in this network we have specified only the passive elements, okay, where you have 4 resistor values and 1 capacitor value. This network can have the active sources also. So the active sources are either voltage or the current sources. Okay, this also representation of a network. Let us see what is the meaning of a circuit. A circuit is also an interconnection of electrical elements, but it must have at least one independent source and one closed path. Okay, so we don't have this constraint. Okay, what is that constraint? At least one independent source and one closed path. Minimum to minimum, a circuit must have one independent source. It can be a voltage or it can be a current, and also it should have one closed path. So after that, whether it is having closed paths or not, but at least one closed path it should have and one independent source it should have. So that means either it is a voltage source or you can represent a current source. So let us see the example for circuit. So this can be considered as example for the circuit where you have one voltage source and one current source. That means it is a mix of the active sources as well as the passive sources, and the circuit is having the closed paths also. Let us see the open circuit. It is an electric circuit, but there will not be any path for the current flow. So this is the circuit representation. So where you have an independent source and also the passive element, but it doesn't have a path to flow. Okay, so the current starts from here, assuming there is a path, but since there is a break of the wire or the circuit, the current cannot flow through these terminals. Okay, this kind of circuit is called the open circuit. So the current flowing through this circuit will be always 0. Then what about the voltage? Since the current is 0, whatever the voltage is appeared here, it will appear across the terminals, because across these terminals we can measure the potential drop. So whatever is supplying from the source, it will drop across these terminals. So the terminal voltage will be equal to the source voltage, which is maximum. Now coming to the short circuit. A short circuit is also an electric circuit where the current has a path to flow. So that means we don't have any break of the wire or the circuit. The circuit will have the active sources as well as the passive sources, and this circuit offers a path for the current flow. So here, there will be a finite current flow. So the current I is equal to source voltage by R using Ohm's law. And if you measure the voltage across the short circuit, it will be 0 because the short circuit allows the full current flow. So there won't be any voltage across the terminals because we cannot measure any voltage across the terminals. So these points are very, very important. Okay. Open circuit, the current will be 0 and the voltage will be maximum. For the short circuit, current will be at maximum but the voltage will be 0. Now let us see what is the meaning of a branch. Branch is an element of a network having only two terminals. Example, you can see here, this is a resistive element. This resistive element is connected between the 2 points. This particular element is called a branch. Your branch can be of any element. It can be a capacitor, it can be an inductor, whatever it is. So every electrical element which is formed or which is connected in between the 2 nodes is called as a branch. Let us see the node. Common point at which 2 or more branches meet together. A node is a point where several branches meet at a particular point is called the node. Most of the people get confused how to take nodes. Okay, for this particular circuit, how many nodes can be represented? Node is a point where several branches connected, in the sense, the meaning of this is from that node there will be a current division. Okay, so that means after reaching to that point there will be several paths available for the current to flow. If that is not the case, that cannot be called as a node. For example, if I represent any of these forms, okay, so you can see here the current is not dividing. It's coming to this particular corner, but the same current is entering into this branch also. Even in this case the same, even in this case the same. So it doesn't mean that if 2 elements are created, or you can see there is a sharp point here, that is a node. That is not called a node. In this circuit, let us see the correct way of identifying nodes if the current flow starts from this source. If you come to this point, for the current, there will be different paths available. Current can flow in this way, current can flow in this way. So, this will be the first node. Now coming to here, for this current, again if you stand at this point and look at, even this current has 2 paths, one this way and another way, this can flow in this way. So this can be a node. Now if you see this current, after coming till here, so again it has 2 different paths. The current can divide either this way or this way. So this also a node. Now if you see the current which is flowing to this R2 branch, once it comes to here, there is a straight path for this. That means only one way is exist from here to here. So there won't be any node on this branch. That means both together will be on a single branch. So now after coming to this point, Okay, so either it is with respect to this current or with respect to this current. So from here these two currents can identify a different path. That means for this current it can flow in this way also, in this way also. Similarly for this current source, and it is having again two paths. One, it can flow to the bottom lane branch, or else it can take this direction. So this creates a node. Similarly, here for this current and for this current there is another path. That means after this point the current can divide into any of the branches. So these are the valid nodes. Now you can see here all together these currents are joining at this particular node. Okay, so that means this is a common node. Okay, this will not create a node. This will not create a node, but this creates a node. This is called a reference node, because whatever currents have divided, here it will sum up and return to the source. Now let us mark all these nodes. So this is our first node, and second, third node, fourth node, fifth and sixth nodes. So this network is having only 6 nodes. So these nodes, whatever the nodes that you have represented on top lane are the actual nodes, and this node is called the reference node or a ground node. So if you want to apply any rule, so you will apply on these nodes, not on the reference or the ground node. Now let us see what is the meaning of a loop. It is a closed path formed by the branches which can also have the other loop inside it. So it is very important for the electrical circuit or the network analysis subject to understand what is the difference between loop and mesh. Some people will keep using interchangeably the loop analysis or the mesh analysis. But these two are different. Okay, these two are not the same. Now let us see first what is the meaning of the loop. So if I say do the loop analysis for this, how many loops can be formed in this particular network means this can be one loop, this can be one loop, and this is one loop, and there is an outer loop also. So you can say that this can be a loop, okay, or else this outer loop can be a loop. So like this you can have the other loops also inside it. So it's not an separate or the isolated loops. So you can have the loops inside the loops. Now let us see what is the meaning of a mesh. Mesh is a kind of a loop which does not have other loops inside it or does not cross another mesh. It's very clear. So if I say how many meshes are there, there are only 2 meshes in this network. So we should not take this as one mesh. Okay, so meshes are the separate loops which will not cross loops each other. So you cannot take like outer mesh or the inside. If any other loop is there inside that loop, we are not supposed to take like that. I hope this session is clear to you. Thank you.